Welcome. In this video, we'll explore the core concepts of inheritance in Java, a fundamental principle of object-oriented programming. Inheritance allows a child class to inherit features from a parent class, making code reusable and organized. We'll break down the different types of inheritance, compare Java with C++, and discuss the limitations and alternatives to inheritance. By the end, you'll have a solid understanding of how inheritance shapes Java programming and how it fits into the broader world of OOP. Java supports several types of inheritance, each with its own structure and use case. The main types are single inheritance, multi-level inheritance, hierarchical inheritance, and multiple inheritance. Single inheritance means a child class extends only one parent class. Multi-level inheritance creates a chain, where a subclass becomes the parent of another subclass. Hierarchical inheritance occurs when multiple subclasses share the same parent. Multiple inheritance, where a class inherits from more than one parent, is only supported in Java through interfaces, not classes. Single inheritance is the simplest form, where a child class inherits from only one parent class. This structure is straightforward and helps maintain clarity in your code. For example, if you have a class animal and a class dog that extends animal, dog inherits all the properties and methods of animal. This makes it easy to reuse code and add specialized behavior in the child class. Single inheritance is the most common form used in Java applications. Multi-level inheritance creates a hierarchy where a class extends another class, which in turn extends yet another class. Imagine a chain: grandparent, parent, and child. Each class inherits features from its predecessor, allowing for a layered approach to code reuse. For example, a vehicle class could be extended by a car class, which is then extended by an ElectricCar class. Each level adds new features while retaining those from above. Hierarchical inheritance occurs when multiple subclasses inherit from the same parent class. This is useful when you have a base class with common features and several specialized subclasses. For instance, a class animal could have subclasses like dog, cat, and bird, each inheriting basic animal properties but adding their own unique behaviors. This structure promotes code reuse and organization. Multiple inheritance allows a class to inherit from more than one parent class. However, Java does not support multiple inheritance for classes due to ambiguity issues, such as the diamond problem. Instead, Java allows multiple inheritance through interfaces. A class can implement multiple interfaces, inheriting their abstract methods and providing its own implementation. This approach avoids conflicts and keeps the language simple and robust. Let's look at an example. Suppose you have two interfaces, Animal and Mammal, each with their own methods. A class dog can implement both interfaces, providing concrete implementations for each method. This way, dog inherits behaviors from both animal and mammal. Java's interface-based approach to multiple inheritance ensures there's no confusion about which method to use, making your code safer and easier to maintain. Inheritance works differently in Java and C++. In C++, a class can inherit from multiple classes directly, which can lead to complex scenarios. In Java, all classes implicitly inherit from the object class, and multiple inheritance is only possible through interfaces. This design choice in Java avoids ambiguity and keeps the inheritance structure clean and manageable, making Java code easier to understand and maintain. While inheritance is powerful, it has limitations. In Java, inheriting everything from a superclass can make subclasses cluttered and error-prone, especially with dynamic overriding or overloading. Tight coupling between classes can make code harder to maintain, and changes in the parent class can unintentionally affect child classes. It's important to use inheritance wisely and consider alternatives when appropriate. Although inheritance is a popular OOP concept, composition is often more advantageous. In composition, a class contains instances of other classes as member variables, forming a has-a relationship. This approach reduces tight coupling and avoids the fragile base class problem, where changes to the parent class can break child classes. Composition also allows for more flexible and maintainable code, as you only include what you need. Association represents a relationship between two separate classes, established through their objects. It's a has-a relationship, meaning one class uses or interacts with another. For example, a teacher and a department are associated if a teacher belongs to a department. Association is a flexible way to connect classes without tightly coupling their lifecycles. Aggregation is a special form of association where one entity is associated with another, but both can exist independently. For example, a department can have multiple professors, but a professor can exist without a department. Aggregation is represented by an empty diamond in UML diagrams and is useful for modeling relationships where objects are related but not dependent on each other for their existence. Composition creates a strong relationship between two classes, where one class contains an instance of another, and the contained object cannot exist independently. For example, a human has a heart, but a heart cannot exist without a human. Composition is represented by a filled diamond in UML and is used when the life cycles of the objects are tightly bound together. Aggregation and composition both describe relationships between objects, but with key differences. Aggregation has a relationship where objects can exist independently, while composition is a part of relationship where the child object's life cycle depends on the parent. Aggregation uses an empty diamond, and composition uses a filled diamond in diagrams. Understanding these differences helps you design better object relationships in your code. In Java, constructors are not inherited. Each class must define its own constructors, even if it extends another class. While methods and fields can be inherited, constructors are special methods used to initialize objects and must be explicitly defined in each class. This ensures that each class controls how its objects are created. Polymorphism allows objects to take many forms. In Java, there are two main types: compile-time polymorphism, also known as method overloading, and runtime polymorphism, known as method overriding. With polymorphism, you can write flexible and reusable code, as the same method can behave differently depending on the context. Runtime polymorphism, or dynamic method dispatch, is a mechanism where the method to be executed is determined at runtime. This happens when a subclass overrides a method from its superclass. When you call the method using a superclass reference, Java decides which version to execute based on the actual object type. This enables flexible and dynamic behavior in your programs. Method overriding occurs when a subclass provides its own implementation of a method already defined in the parent class. The method must have the same name, parameters, and return type. Overriding is a key way to achieve runtime polymorphism, allowing subclasses to define specific behaviors while sharing a common interface. Method overloading allows multiple methods in the same class to have the same name but different parameter lists. This is known as compile-time polymorphism. For example, you might have several multiply methods that accept different numbers of parameters. The compiler determines which method to call based on the arguments provided. Static methods in Java belong to the class, not to any object. Because of this, static methods cannot be overridden. If you declare a static method in both a parent and child class with the same name, the method in the child class simply hides the one in the parent class. This is different from true overriding, which only applies to instance methods. In Java, you can overload the main method just like any other method. This means you can define multiple main methods with different parameter lists. However, only the standard main method with the string args parameter is used as the program entry point. Other overloaded versions can be called from within your code as needed. Private methods in Java cannot be overridden. Since private methods are only accessible within the class where they are declared, subclasses cannot see or override them. If you declare a method with the same name in a subclass, it's simply a new method, not an override. When overriding a method in Java, you can widen the access scope but not narrow it. For example, if the parent method is public, the child method must also be public. If the parent method is protected, the child can be protected or public. This ensures that overridden methods remain accessible where they're expected to be. When overriding a method, you can modify the throws clause, but with limitations. If the superclass method declares exceptions, the subclass can declare the same, narrower, or no exceptions. However, the subclass cannot declare broader exceptions than the superclass. This rule helps maintain compatibility and predictability in exception handling. Java supports virtual functions by default. All non-static, non-final methods are virtual, meaning they can be overridden in subclasses. If you want to prevent a method from being overridden, you can use the final keyword. This feature enables dynamic method dispatch and flexible code design. Abstraction is about representing essential features without including background details. In Java, abstraction hides complex implementation details and exposes only what's necessary. For example, you know how to drive a car without understanding how its engine works. Abstraction helps manage complexity and keeps code clean. An abstract class in Java cannot be instantiated directly. It may contain abstract methods, which are declared without implementation, as well as regular methods. If a class has at least one abstract method, it must be declared abstract. Subclasses must provide implementations for all abstract methods, making abstract classes a blueprint for other classes. Abstract methods are used when you want subclasses to provide their own implementation. The parent class defines the method signature, but the actual behavior is left to the child classes. This is useful for defining a common interface while allowing flexibility in how each subclass fulfills it. If a base class implements the serializable interface, but you want to prevent serialization in a child class, you can override the writeObject method in the child and throw a not serializable exception. This approach gives you control over which classes can be serialized, even in an inheritance hierarchy. The Java collection framework is a set of interfaces and classes for storing and manipulating groups of objects. It includes popular classes like ArrayList, Vector, LinkedList, PriorityQueue, and TreeSet, as well as interfaces such as Set, List, Queue, and Deck. The framework provides a unified architecture for working with different types of collections efficiently. The main interfaces in the Java collection framework are collection, list, set, queue, deck, and map. Each interface serves a specific purpose. For example, list allows ordered collections, set ensures no duplicates, queue manages elements in a FIFO order, and map stores key-value pairs. Understanding these interfaces helps you choose the right collection for your needs. Array lists are not synchronized by default, which means they are not thread-safe. To synchronize an array list, you can use collection synchronized list, or copy-on-write array list. The first method wraps the list in a synchronized wrapper, while the second provides a thread-safe variant that handles concurrent modifications efficiently. You might wonder why we use ArrayList when Vector is already synchronized. The answer is performance and flexibility. ArrayList is faster and supports multithreading, while Vector is limited to single-threaded use and is considered outdated. ArrayList is generally safer and more efficient for modern applications. Java does not allow the creation of generic arrays because arrays carry type information at runtime, while generics use type erasure at compile time. This mismatch can lead to runtime errors like array store exception. To maintain type safety, Java prohibits generic array creation. Regular arrays in Java store elements in contiguous memory locations, making access fast and predictable. Array lists also use contiguous memory, but they can grow dynamically. When an array list exceeds its capacity, a new, larger array is created, and elements are copied over. This allows array lists to expand as needed while maintaining efficient access. To convert an array list to an array in Java, you can use the toArray method. For example, listObject to array new string list object, size, returns an array containing all the elements of the array list. This is useful when you need to work with APIs that require arrays instead of lists. To convert an array to an array list, use the ArraysAsList method. This creates a fixed size list backed by the original array. For example, ArraysAsList temp converts an array temp into a list. This method is handy for quickly turning arrays into more flexible list structures. Array lists grow dynamically as you add elements. When the current array reaches its capacity, Java creates a new, larger array and copies the elements over. This resizing process ensures there's always room for new elements, making array lists flexible and efficient for dynamic data storage. The vector class in Java is similar to ArrayList but is synchronized, meaning it's thread-safe. Vectors use a dynamic array to store elements and provide methods like add, remove, and get. However, because of their synchronization, vectors are slower and less commonly used in modern Java programming. You can make an array list read-only using collections, unmodifiable list. This method returns a read-only view of the original list. Any attempt to modify the read-only list will throw an unsupported operation exception, ensuring your data remains unchanged. A priority queue is a special type of queue where elements are ordered by priority rather than insertion order. In Java, priority queue is based on a priority heap, and elements with the highest priority are served first. This is useful for scheduling tasks or managing resources where order of importance matters. The linked list class in Java uses a doubly linked list to store elements. It maintains insertion order and can be used as a list, stack, or queue. Linked lists are not synchronized and are best used when you need fast insertions and deletions rather than random access. The stack class in Java implements a last-in first-out LIFO data structure. It provides methods like push to add items, pop to remove the top item, peek to view the top item, empty to check if the stack is empty, and search to find an item's position. Stacks are useful for managing function calls, undo operations, and more. The set interface in Java represents collections that do not allow duplicate elements. Common implementations include hashset, which stores elements in a hash table for fast lookups, linked hashset, which maintains insertion order, and treeset, which stores elements in sorted order. Sets are ideal when you need to ensure uniqueness in your data. We've covered a wide range of Java OOP and collection concepts, from inheritance and polymorphism to the details of the collection framework. Understanding these principles is essential for writing robust, maintainable Java code. Remember, choose the right tool for the job, whether it's inheritance, composition, or a specific collection type. Thanks for watching and keep exploring Java.